according to classical mechanics, if we keep heating our black body radiator up, it should start to emit a lot of UV light, and even X-rays and then gamma rays. But it turns out that's not actually what happens. This is what it actually looks like. So you can see that these two don't agree with each other. Classical physics predicted that the graph should look like this, but if you really measure it, it looks like this. So something is wrong here, and this is called the ultraviolet catastrophe. And the reason they named it that is because it would predict that if you just heat something up, you should see a lot of ultraviolet light coming off of it, when in reality you don't. So why is it that these two don't match each other? If you say that any atom in your black body radiator can have any energy, then you end up with an equation like this, which is B, which is just kind of another term for intensity. It's called spectral radiation. You have B equals the frequency squared times 2 times Boltzmann's constant times temperature over the speed of light squared. So this is the equation that makes your plot look like this, where it kind of just goes off into infinity. But then a physicist named Planck came along, and out of the blue, just to get his math to fit the realistic equation that looked like this, he said, well, what if we just don't let the atom have any energy that we want? What if it only has these quantized level of energy, so it can only have these certain energies? If we do that, then this equation becomes this equation. And it turns out that if you only let the energy of the atom have certain values, then what you end up with is a plot that matches real life instead of this fake thing where it just goes off into infinity. And this is now known as Planck's law. And it turns out he didn't have any real physical reason for doing this. He was just trying to get his equation to match what we see in real life. So before, they used to think that when a photon hit an atom, it caused the atom to vibrate, kind of like a ball on